So yeah, the little hook I had for this session is the question that we're going to be exploring is that can you become a data scientist in less than or equal to 30 minutes? I thoroughly believe that this is possible, and I believe so because of the following. The three things I'm going to try and do in this short time is demystify data literate people can be very guilty of just clouding simple concepts behind complicated terms, and I don't think that should be the case anymore. We're going to try and demystify as much as possible. And then the next step, kind of objectify. It's one thing to know, to now know something is simple versus complicated, but it's another thing to know the 3, 5, 10 steps that it takes to actually do the simple thing. So we're going to try and do that as well. And I've made a supporting document which does most of the step-by-step and the sharing of important questions. So you'll have that sent around after the session too. And then finally, just empowering. I won't be able to shout loud enough in this deck about how eminently possible it is that everybody can make data science part of their kind of daily life, and regardless of your historic relationship with numbers and data, you can do all of the things that it takes to be an accurate and very confident and complete kind of data science doer and data scientist. So to that end, like, why bother doing any of that in the short term? And I had that survey, so thank you if you filled out the survey that I sent round. A few interesting things came out of it in regards to why we should bother running sessions like this. So first of which is kind of reducing a level of parity in the agency. So there was those two opening questions around like evaluating your ability to draw insights from data and your comfort and confidence having data related conversations. And what we noticed was there's this wide spectrum across the agency in levels of confidence in terms of working with data or having conversations. And if through sessions like these, we could reduce that parity whilst also sliding our average confidence up, then that will mean the more data conversations we can have in the building and the better they'll be, which is obviously really important for any business, particularly one like ours in the 21st century. The second thing is just having a chance to like empower people and change their mindsets. So in response to agreement with the statement, I'm just someone who has never got on with numbers, data is just not my thing, is never likely to be my thing, respondents fell into kind of neatly into one of three sections. So we had about a third of the agency who disagreed with that sentiment, and actually they felt quite confident with numbers, a third in the grey that were unsure, and another third who thoroughly agreed, bit strongly in the deep red or just a simple agree in the pink, that yeah, actually they never really got on with data. So actually we've got an opportunity here to perhaps change the mindsets of 2/3 of the building and to go from seeing themselves as not data like happy to being very data happy, and that meaning more confident and kind of data savvy people in the building is really transformative. So another good reason to run a session like this. And finally, provide skills and growth, which is what people seem to desperately want from their jobs nowadays. And this was typified in the last survey question, which like no fewer than 100% of respondents said they would relish or at very least tolerate data focused training at work. So I'm very happy to be the provider of this and to run as many sessions like this as there is enthusiasm and appetite for. So to that end, this deck is packed full of stuff because I believe I can communicate lots of stuff in a short time that will all empower you to feel like data scientists. So write down things if it's useful to you, but rest assured I've written this little document that does lots of the step-by-stepping and demystifying and objectifying that I've said is why we're here and doing this in the first place. So write things down if you want, but don't worry if you just want to listen and enjoy the session for the next what it is. Cool. So here we go. This is going to be a very full next 22 minutes, but I hope it's really enjoyable and valuable. Firstly, everybody can do data science based on what I've learned and understood for 4 key reasons. and I've given each a little pillar. Firstly, that there are no barriers to tools and training and data. So to be a data scientist and do some exceptionally powerful and sophisticated things with data, you just need a laptop, a data set, and a connection to the internet. All of the tools and little things you need can be either found in your browser or downloaded by Andy and or myself, so we can all have access to everything that we could possibly need to do data science in a really big way and really interestingly. Also, the spectrum of data science goes from the kind of simple and straightforward to the complex and complicated. So if we can move everybody, regardless of confidence, just onto that spectrum and to know that even if you're doing something simple and straightforward, that is as valid, providing you're doing it obviously accurately and communicating it well, as something much more complex and complicated. You don't have to have this kind of imposter syndrome. You straightforward and simple and accurate is really good. Thirdly, that the whole discipline, data science as a discipline, is defined by its outputs and not by expertise. You don't have to have some highfalutin degree or, as I've said before, access to kind of really specific technical equipment to do it, providing you can do the 5 or 6 key skills and steps. You're as valid a data scientist and doer of data science as anybody else. And finally, that usually data specialists like to keep processes and outputs behind smoke and mirrors. And to be honest, I'm not interested in that dichotomy anymore. I'd much rather work with an agency of people who was really empowered, who had a high level of understanding, and we could have loads of interesting conversations versus me, or indeed anyone like me, feeling like the only go-to specialist. So to that end, we'll pick apart some of these pillars as quickly and as clearly as possible. So in one of the textbooks that accompanied my course, someone had a definition for data science as something that data scientists do. Obviously, on the face of it, that sounds like quite a glib and lazy description, but actually it's quite empowering, because it means that any one of us, providing we know the outputs and can have them clearly explained and know how to execute them, can be and do data science at a really good level. So I've constructed a definition for a data scientist as follows. A data scientist is someone who finds solutions to problems by testing their hypotheses through the analysis of data, using the appropriate tools, and then tells captivating stories that motivate unified action in collaboration with relevant stakeholders. So, to make this abundantly clear, as soon as you can identify problems, and I bet we can all do that already. This is very much a part of every one of our working lives, regardless of our roles. 2, as soon as you can create a hypothesis, and I've got a section, a nice easy framework through that teaches people how to do that later in this talk. As soon as you can analyze some data using some helpful tools, and that's possible to also attack in the time we have today, and then tell a story about your findings in which the data is a clear, compelling component, and we'll come to that later as well. As soon as you can do all of those things, you are doing data science and are a data scientist as a result. So to continue to make this clear, as well as demonstrate how the spectrum of data science goes from the simple and straightforward, if we thought about any role and a data component within it as existing on this graph, with complexity on your vertical axis and accuracy on the horizontal axis, and then the size of any one bubble being the amount of data that someone has available to them. Think of a hypothetical person called Kylie, who is the chief operating officer of an educational tech startup. They launched their tool a couple of weeks ago and are just starting to get kind of user behavior data through their application. And this is testing some of the initial assumptions they made on which they built, obviously, the platform in the first place. Kylie then looks at these assumptions and then shares some of the learnings with her development team and then with the investors. Kylie's doing data science there and is therefore a data scientist. If you think of a perhaps more typical description of someone like Gerald, who's a senior data analyst, perhaps for a big financial services company, and he's creating kind of complex, sophisticated models that are pulling on all of these different financial indices and measures and trying to make predictions around like the validity of any future investments. And he's having conversations with obviously his team of insight analysts and obviously bigger stakeholders in the business. He's perhaps more obviously a data scientist than Kylie, but both are equally as valid and act exactly the same. To someone like Cassandra, perhaps, who is an account manager who has finally managed to wrestle that last quarter's sales data off their client, because she's had an inkling that they're just targeting the wrong segment of people with some of their out of home. And she's able to pick this apart, make a simple graph, and then share that in a monthly status meeting. Cassandra, despite what she's doing being less complex, it's still accurate. It's still tested an assumption or a little hypothesis that she's had, and she's managed to communicate that in a way that drives some action. She's as valid a data scientist as anybody else, indeed, in this spectrum. So, yeah. Simple and straightforward is as valid as complex and complicated, providing it's accurate and everybody can do it. You don't have to feel any imposter syndrome about doing something smaller and more focused. Next, data science is a process and not an event. So in no single instance in the process will you be doing data science in isolation, but when you put it together as an end-to-end process, that is data science. And this is something I'm keen to be very transparent about and make as simple as possible. And most of the simplicity behind this is in that accompanying document I've made, but we're going to walk through it here is in a kind of metaphorical way, thinking of ourselves and the process indeed as a caterer who's just had the offer of a new client to do a meal in a couple of weeks' time. So the start of this process is the business understanding analytical approach sections, which is tantamount to the caterer sitting down with his new client and really getting to the heart of why they want the meal in the first place and what their relationships with certain types of food are and what their limitations are in terms of budget and scope, and getting to the kind of the deeper contexts that are driving the want for a meal, which, just like in a data sense, is a problem that you are trying to solve as the caterer. And then the analytical approach section is the caterer going away from said discussion and thinking, okay, well, with all of this learning I now have, how do I think I'm going to approach this task? Like, what kind of problem am I solving? Like, how would I have to present the food and share it, etc. in the end? So just doing some of that upfront thinking. After you've done all of that, then you get into your data sections, which move through data requirements, collection, understanding, and preparation. And this is exactly the same as a caterer going, okay, well, now I'm confident about how I want to approach this. What ingredients am I going to need to build out my meal, which is the requirements section. Obviously, where and how and when you source these ingredients is the collection step. And then as you're walking around the grocers and you're prodding and you're understanding, you're checking for bruises, you're maybe having a little taste just to make sure that you understand and actually what's in the ingredients is doing exactly what you need it to do, is the understanding step. And then when you get all of your necessary ingredients home and you start chopping and splicing and caramelizing and whatever you need to do to prepare it for your eventual dish, that's the preparation step. And this may be a loop that you go through a few times as maybe what you've collected isn't quite as representative of the problem you need to solve as it could be, and maybe there's some more greater preparation required. Next, and the final little loop is modeling, feedback, deployment, evaluation. And we'll come to this a couple of times. A model sounds like a convoluted term, but really it's just your approach to solving a problem and the answer that you get to. And obviously in our cooking example, that's you testing and making the dish first, and then obviously testing it as you go and learning about it as you're making it. And then you'll go through some feedback internally to give for some people who are invested in the project but aren't your final client to get feedback. And you'll go through that loop plenty of times until you've got sufficient confidence that you can deploy your model, you can serve your dish to the person it needs to be served to, and they will understand it. It will meet every measure of their success, and that they will be able to feedback on it and evaluate it, so there can be this consistent delivery and usage of it. So there's lots of steps in there, and there's lots of questions and stages in each one. But if we think of it as a caterer, it perhaps makes it a bit more easy to do, and the document will help shed light on any of the more specific data bits. But data science is a process and not an event. Next, so as I've kind of said, and this is a real empowerment bit, is that you are not trapped by having limited ability or by not having felt comfortable with numbers in the past. And here's why. Why is because to be an optimally successful data scientist, you have to have the right mindset first, and then you have to pass said mindset through any number of helpful frameworks, a few of which we'll get to here, and then only then is it a consideration on what kind of level skills you have, and we can make sure that in training sessions like these that everybody has got the fundamental skills to feel confident in doing that. And actually any 3-stage hierarchy that goes into a PowerPoint might as well be mocked up into a pyramid. So we'll go through each rung of the pyramid now. Firstly, mindset. So what are the 3 key tenets of the data science mindset? Firstly, you have to be curious, which means you've got to have a passion for what it is that you are looking at, and you've got to want to know more than currently is known indeed by you or exists in the knowledge base of the team of which you are a part. That's an essential trait. Secondly, you've got to be skeptical, which means you've got to be prepared to challenge perceived wisdoms or see perceived wisdoms as a thing to challenge, and be detail orientated, which means you've got to treat every single detail, all of which that are laddering up to and contributing to the performance level of anything that you're approaching at together, and see everyone as having the opportunity to be evolved and improved through your data analysis and hypotheses, etc. And finally, you just got to be a bit courageous, because eventually, because of that process that we've talked about before, you will have understood loads about the business and prepared your data in such a way so it's truly representative of the problem to be solved. And you've gone at creating your models again and again and again, so they're really watertight. And it will come to a point where you understand something that everybody else in the room might not. And your sharing of this might challenge some of the assumptions that they hold, and you might get a few confrontational questions or a bit of particular scrutiny in those moments. And just having courage and just sticking by what you've found and communicating it with sensitivity and tact is a really important and key trait to be a successful data scientist. Secondly, second level, we've got a few frameworks that I can communicate in the time here, which are really useful mechanisms for just treating either end of the data science process in a way that's going to limit the number of mistakes you make and amplify the quality of your insights and communication. These 3 frameworks are as follows: how to write, obviously, a proper hypothesis, how to tell a story, and the 80-20 questions. So we'll tick through those quickly, one after the other. So firstly, how to write a hypothesis. A hypothesis has 4 elements. It has a title, it has a description, it has obviously an endpoint, and it's got a way of being measured. So if we treated this training session, and indeed any that follow, as a way of filling in this hypothesis framework, we'd say the title was Increasing Data Empowerment at a Hey Human, because obviously that's the focus of the time and the thing that hopefully we'd be trying to test, or an assumption we'd try and evaluate. The description is really the story of which, or the narrative that you want to be validating by the measure you select. So, and you can write it out as simply the belief that you currently hold. So I say, I believe that regular data training sessions will improve agency understanding of and confidence using data. I stick an endpoint on that, which is following a third training session. And then I say, well, my measure of this is that survey score at the beginning. And if I can reduce the range, the parity that we see and our average, then if I see an improvement indeed, then I've validated my hypothesis. If I don't or see a decrease, then I've kind of devalidated it. And obviously I've learned something fundamentally different. So title, description, measure, and end is a very useful hypothesis framework. Secondly, how to tell a story. I think we're all very used to, in a kind of business or corporate setting, leading with our insights and recommendations, and then having it's a slight battering ram approach. It's like evidence, 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 evidence after that. And that's fine for providing a level of clarity in terms of an idea, but it's not necessarily great for motivating the kind of unified action that I described in my data scientist kind of definition. And that battering ram approach is a bit like if you had a murder mystery and you use the first 5 or 6 pages to go, okay, so the butler did it, and he did it with the secateurs in the conservatory. And the only reason he could have done this was because that he was the only one that had the keys past midnight, and he knew that Mrs. Bothelswaite was coming back a day early and then wouldn't have an alibi. You just laid out all of the evidence right at the start, which is good for understanding why the murder occurred, but it's not necessarily great if you want to play on the emotions and really create a captivating story that someone feels invested in throughout the telling of it. So to that end, what are the 3 kind of helpful ways of communicating a story through data? Well, firstly, you want to contextualize the problem by putting the facts on the table. So like any of the measures and statistics that are creating either the problem you've found or the ones you need to wrestle to get to a kind of more successful place, be transparent about them and put them on the table at the start. Reveal those characters and highlight the conflict that may exist between them. Secondly, just take your audience on the route that you've experience from some of those characters and the sharing of those problems on the way to the insights. And as you do this, obviously, this gives the audience time for pauses and reflection, and they're going on the journey with you as you are going on it yourself, and as you're communicating it with them, obviously all the time constructing their own thoughts and assessments and coming to different conclusions in their own mind. And then finally, resolve that kind of those reflections and pauses with the evidence. So, which means aligning your insights with those planted in the minds of the audience. So, and that's the ultra motivating part, is when because of the journey you've taken, the audience will come to inevitably some conclusions that will feel very similar to yours. And then when you present evidence, it highlights in their mind, oh, look, well, I had that kind of idea. They've been very self-invested throughout the process. They feel like they've been communicated to transparently and honestly, and not just had opinions forced upon them. If you can stick to that framework of being honest and contextualizing problems at the start, taking the audiences on the journey to the solution, and then resolving with evidence and engaging opinion throughout, then you're going to get much more captivating outcome. And then the 80-20 questions are very simple. They're all laid out in this document that I provided. There are gaggles of questions that you can ask at every stage of the data science process, which, regardless of what you're focusing on, will always help you avoid the key mistakes and get to some important answers. Obviously, it will always take some more domain specific questioning to get to the kind of deepest answers, but there are some that will get you all of the way, most of the way, and they're referred to in this document I provided. And then finally, in this pyramid, we've got data skills. And we're going to demystify some of those now, because as I see it, there are three key kind of silos of data skills that we'll all need, and that actually they're locked behind some unnecessarily complicated names. And a way of sharing this and demystifying in a fun way might be to go, some people may be familiar with this, which was one of Obama's last White House Correspondents' dinners. And there was a Key and Peele skit character at the time who was Obama's anger translator, because obviously Obama was criticized for being very mellow and perhaps holding in some of his anger, and this played off it. The anger translator was kind of saying how he really felt down inside in a more kind of simple everyday terms. So we're going to do that with the three silos of important data skills. So there's a million different ways of saying what is the first silo. So like it gets called data transformation and pre-processing, manipulation and wrangling, which are all convoluted ways of saying that you want to make sure the data can do what you want it to by deleting the bits that you don't need, making sure you don't later forget the cool acronym you made up, what that stands for, and that checking any missing values aren't causing the whole thing not to work or completely reversing your apparently game-changing insight. So it's like a convoluted, perhaps scientific, complex term, which really strictly means only use the data that you need. Don't confuse yourself, and take care of any missing values responsibly, so that the data you have is really representative of the problem that you have to solve. The next key silo is statistics and modeling, and we're going to treat that in the same way. Obviously, statistics is a very kind of anxiety-inducing word, because it makes us think of all of those maths and calculus lessons we did or did not have at secondary school and sixth form. But really, in the data science world, to me, that means using simple formulas to improve accuracy, all of which any tool or programming language makes it very easy for you to use and understand. Like I could communicate 80% of the important formulas to use and how to do them in Excel and in Python in approximately 15 minutes in a way that everybody would understand. And so therefore there shouldn't be any miscommunication or worry about the use of or understanding statistics. And as we talked about earlier, a model can be very complicated, but in truth, it's just your approach to solving a problem and the answer you came to. So like whenever you see model floated in any data deck or whatever, don't worry that you wouldn't never be able to understand its complexity or do it. It's simply someone's approach and the answer they got to. And finally, data visualization is the final big silo, which obviously just means share a graph that people actually understand. There's no kind of more convoluted mechanism than that. And we can actually explore this a little bit, and because the key lesson is just less, as simple as possible. It's often said as a measure of great art that it wasn't that there was nothing more that could be added, it was that there was nothing more that could be taken away. It was kind of at its simplest. And hopefully we can come back to the example I had at the start. This is two pie charts, obviously the one we saw at the beginning, and the same data with more elements on it. It's got data labels, it's got a legend, it's got more colors, but ultimately doesn't do even half of the communicating about the core insight about empowerment and people's opinion as the one on the left does, obviously despite having many fewer elements. Finally, we're going to try and take the same demystification approach to machine learning in what time we have here. And this will take approximately 3 or 4 minutes if you're worried about the time as it stands now. Machine learning, I've noticed, tends to get bucketed in one of two ways in people's attempt to make it simple to understand. Often it will get a definition like this, is that machine learning is the subfield of computer science that gives computers the ability to learn without being explicitly programmed. That doesn't mean anything to anybody and doesn't go even a fraction of the way to helping anybody actually understand what's happening. And equally, if you find any video on YouTube that tries to break it down, often you'll just get a kind of kitsch set of graphics, which are probably grossly oversimplifying what is actually a more interesting and complicated process. So I thought, well, what steps represent the heart of the discipline that are based on what I've learned, and how would I have liked them communicated to me when I was just starting. So I'm going to try and do that here in just 3 or 4 minutes, and we'll look at a notebook, hopefully, which is where lots of this machine learning can be done. So firstly, it starts obviously with data. And in our kind of learning example that I'm building off here is an example of like a medical diagnosis. So in our data set, we've got obviously age and gender, categories of a person, and lots of measures. This is looking at the size of a tumor and it's some of its qualities, its adhesion, etc. And then each one of these things has defined the tumor as being malignant or benign, so either dangerous or not. When looking at this through a data science lens or a machine learning lens, you can break things down as follows. So each of these categories, age, gender, clump, etc., is called an attribute. And each column, which is the attribute plus all of the rows of information, is called a feature. Each row is called an observation, and each cell that obviously joins the rows and the columns is called a record. In machine learning, each row can be considered as another experience that the computer can then draw upon when making predictions of similar records with unknown features, and that your ability to turn this experience into a prediction just means selecting the most predictive features in terms of the ones that, they're the ones that are actually going to help you make the most accurate prediction. So if we look back at these features, obviously we'd want to know the kind of clump size and the uniformity and the kind of adhesion of the tumor itself. And age and gender may be helpful, but not particularly indicative. But as in, like, whether someone came into the GP surgery wearing a hat or not, this has nothing to do with our ability to predict at all, or at very least has an accidental correlation. So if we were to turn this data set into one that we could do machine learning upon, would mean picking all the features that we wanted to use in our model, the ones that were most predictive, and we'd assign that as the X. And X is not a complicated data or scientific term. It's simply a variable name. X and Y are just names of variables, and you could define them. You could give them any name. But anyway, the features you want to use in your model is the X, and what you're trying to predict is Y. Which in this case, obviously, as we saw, is for this new person, this 52-year-old man who's come in with demonstrating these attributes. Well, what's the status of his tumor? And then in the notebook, as we'll look at in a minute, there's loads of different what are called packages and libraries, which is the machine learning element itself that can help you approach the problem in the right way. So this one on the left is called the K nearest neighbors package or algorithm, because all of the processing that the package does can then assign a numerical value that it would be impossible for you or I to do any statistics to predict. It requires loads of computer processing onto a vector, onto a graph, and then looks at its nearest neighbors and what classes they have to then give an assigning there. So if you'd have picked a K nearest neighbors and your K was 3, you may come away seeing that assigning this star as a purple blob. But if you picked it as 6, it would be a yellow one. So that's an example of one, and a decision tree classification, as we see on this other side, is another, which obviously is just plotting different of the features that you've picked, trying to find the way in which that when you get down the most rungs down the decision tree, you get the most isolated and clear recommendations for the right obviously benign or malignant prediction. And training the data is something that often gets bandied around as well, which is as simple as using a package which is called the train test split to turn your data set into 4 chunks, and a training half of which half a section of it is just the X data and half a bit of it is just the Y, and the same for the X and Y on the test data on the other side. And then you can do, because obviously if you're predicting this feature here, like obviously we don't have it for this person and all of the experience exists in here, so if I split this up into 4 and have half as training and half as testing, I can I obviously have the answers to the test when I'm training it, so I can see my accuracy. And we will hopefully, if you can still see my screen, like this is just an example of a space in which you can do that. Like we can all have access to these, and these are called notebooks. And just to walk you through that process we've just gone through now.
I think we can just still see your PowerPoint.
Cheers, Liz. That's a useful intervention if I've ever heard one. I'll quickly switch it over because it is, I do find it empowering just to see the space in which these things happen, because then it's not scary anymore. It's not something you couldn't do yourself. Where's my, there we go. Okay, so perhaps you can see this now. So yeah, this is what's called a notebook, and this is a space in which all of us would do any machine learning that we wanted to do. And to go through that process that we've just described is simply like you go through a stage where you import the packages that you will then later rely on to do different things. You'll get your data like into this program, which again is just, look, it's just one line of easily written code here. You'll then do that pre-processing transformation that we talked about, which again is just a convoluted way of deciding what it is that you want to see and making sure it works in the way that you'd like it to work. You'll then do that, import that train test split package that I talked about, and that's how it looks like when it's splitting up an X for training data and an X and Y for test data. And then you just import another one here. So whilst I'll never be able to do justice in this short time to perhaps some of the more complicated factors here, like this has gone through, this little thing has gone through making a prediction of what the right drug is for a certain patient in 5 or 6 boxes. Like machine learning isn't a convoluted and complicated thing that only people with decades of experience you can do. We could quite easily do training sessions internally that could empower and get everybody to understand it. Yeah, so to that end, I will give anybody and everybody an opportunity to say something, because I have been talking for hopefully approximately half an hour. I've been trying to keep track of the time, and I know we started a bit behind. Yeah, a lot said there, but I hope that you come away feeling that you are definitely capable of doing data science and feeling like a data scientist. It's something that we can constantly empower and make available as information and training internally. And it seems to be coming at a good time in regards to the evolution of the Hay Lab. And that, yes, some of the basic skills and stuff have been transferred to you too. So I'm hoping more of you feel like data scientists than perhaps you did somewhere between 30 and 40 minutes ago. But yeah, shout if you've got any questions. This will be available as a recording if this has worked properly. Yeah, just let me know if you've got any thoughts.
Well, I'll just say thank you. Thanks. I appreciate that during your time off, you've taken the time to educate yourself, whereas I just drank wine and ate food. So thank you for spending the time on doing this, because it was really good. I think what struck me is, if anyone's ever seen a traditional media agency report, not all of them, but a lot of them are 1,000 rows of data or columns, or just, yeah, baffling. So I would very much agree with less. Focus on the important stuff. So yeah, that was a standout group for me.
Yeah, cheers, Laura. Yeah, no, it was such an enriching thing to do, and I'm grateful for the agency of dedicating some training budget to it. And I'm trying to find the next best kind of more advanced one to do. So obviously to help fill the need that we have internally and the greater focus on data science. So yeah, I've tried to do as much as I can in this short time. But yeah, many more detailed or focused training sessions that hit other skills, like you've just making a simple graph or doing some simple analysis, could easily be done to another time.